Well, today we will replace A3 ADC board again and see if this can fix the meter. I'll use gloves this time because I don't want to get the PCB surface dirty, and this ADC is already tested, so it should be good. Okay, we're ready to go, and this is the new board. I'll step it aside for a moment. We don't actually need this side, so I'll flip it over. Cover not mounted to anything because I was replacing them almost every day. Here's the board which I have now. I'll just carefully take it out. It's have drift about 0.2 ppm per day, so it's not that bad, but definitely not the one I would like to have in this meter. Okay, let's take it out. Even with the gloves, I still will touch board only by corners to prevent any possibility of contamination. It all look really clean, and this board was made in 2004 according to the date codes. It have interesting bodge from Hewlett-Packard, replacing obsolete comparators. It's socketed, so this board is separate, it's not soldered on. Okay, I'll just put it in and see if it works. Connect optics. Okay. As you can see, I don't have the receiver on the A6 board, but that's external trigger only, so I don't care about that for now. If I can confirm that everything is working fine, and I'll just replace the receiver on the A6 board and leave it as it is. Okay, like this one. Okay, everything tight and nice. Let's put the cover back in and do a test run. Okay. Alright, first try. So far so good. Now I'll connect my 10-volt source, which is modified 3245A over here. If I Okay, it's connected. Now, since the ADC is different, of course it doesn't read 10 volt exactly, so I'll have to calibrate the unit a little. But I'll let it warm up about 5 minutes, and also I'll run self-test before doing the calibration. You can try different NPLC settings. 1, 10, 100. It's working as expected. I'll leave 10 for now. Check resistance. Reading gigaohms, that's correct. Check AC voltage. Reading is present, no problems. Temperature. We can try to run self-test. Might be too early because the voltage reference is not warmed up yet. Yep. So it's reading error. Let's go back to 10 volt. The reference chip used in this meter is not stock LTZ1000A, but LTZ1000, so it takes a little bit warmer to get stable reference voltage. Let's try again. Yep, need to wait more. It usually takes about 10 minutes to get self-test pass. Alright, I think it's settled down long enough. Let's try self-test. Okay, everything good. So now we can calibrate to 0, 0 and 10 volts, and then we can run data logging for a couple days and see if it's stable. I'll toggle the front terminals and use my 4-wire short to calibrate 0. Of course, it's not the right time to calibrate because the meter is still cold, so I'll redo it after a couple days non-stop operation. But right now we just want to see if it's stable. Sometimes calibration for 0 is a little bit tricky, so it may not pass from the first time. While it's running, I want to show you some extra stuff I got here. Like this. And like this. Which are guideline resistance standards. This one is labeled as broken. Internal short or leakage for teardown. And this one is actually a good one. This one is 100 ohms and second one is 100k ohm. They are covered in oil because this kind of resistors, they are supposed to be operating in oil bath. So it will be interesting to see what's inside. Try to fix this bad one and do some testing. One of the first tasks which this 3458A will run, if everything is stable and working fine, it will be temperature coefficient measurements for various resistors I have here, and also voltage reference comparison. I'll also use my Keithley 2002 and 2001, so it will be interesting test. Okay, 0 is fine. Now let's run 10 volt. Remove the short. Connect 10 volt source. And calibrate 10 volt. Normally I should let meter run for a couple minutes after I change connections and cables, because temperature change from my hand can easily upset calibration and measurement. So if you want to calibrate meter for the best performance, let it sit for a while and get this equal temperature for both terminals. So far so good. Running ACAL. Okay, now it's calibrated to 10 volt source and we can start test. Warm up 3 degrees since we tried last time. Now GPIB code is running. It's the simple Python application which I already show on xdevs.com datalog_comp. That page also shows all the graphs from different 3458As measuring 10 volt sources. So it will be nice to compare and if this unit is matched to others. Oops. Sorry. Shouldn't be ohms mode. I was running some ohms testing before. Alright, this is our baseline. It will still go up or down as the meter warm up, but after it's reached its stable temperature, I hope it will be stable. That's it for now. I hope you like it. Bye bye.